Okay, we have one last topic. Who would like to give me a good example for a continuous random variable? You do realize the exams on Thursday, right? Okay. Yes, Sebastian.
Amount of time spent on the phone per day.
Amount of time spent on phone per day. Okay. What else? What's a good example?
Amount of miles driven on our cars.
Amount of miles driven. Okay, we'll keep that. What else? To somewhere, from somewhere.
Like, that's shown on your dash.
Oh, okay.
So, like, total miles driven in your car.
That still work. Do we know that number?
No.
How many of you know that number? It's not bad. We'll keep that example. What else?
Amount of time spent on homework every week.
0. Do you guys do the homework? I'm sure some of you started tonight, will be starting it tonight. That's a good example then. What else? Homework in this class or homework in general?
Homework in general.
In general, okay. One more and we can pick one.
Amount of time you spend at the gym per week.
Time spent at the gym per week. Okay, so which one should we go with? So time spent at the gym, the miles that your car displays, the time spent on homework. What's the other?
Time spent on your phone.
Time spent on your phone. You see, I don't do that often. That's why I don't remember. Which one should we go with?
Phone.
Phone, okay. Per day, Sebastian?
Yeah.
I'll start with you.
I guess according to like that app thing that like shows it, I guess like 3.5 hours a day.
Like 6.5?
6.5. The person in front of Dominic,
2.5 hours.
7.4.
ladies first call.
Oh, 5.5.
Three.
1.
No, not, yeah, 2.6.
Like 5.
Three point five.
3. Right.
Sure.
I say 3.
Many of you are lying, but that's fine.
6.
Your turn.
6 as well.
Maybe 2.
2.
4.
3, 2, 1.
7.
Do I have enough? No.
5.4.
6.2.
3.3.
4. 2.
4.5.
Jesse.
4.8.
Maybe 5.5.
Like 5.
3.
4.2.
There is a reason why I'm going for a really large sample.
I don't know.
3.25.
6.
4.6.
5.
Amanda? No, Maddie.
Wait a minute.
Yeah.
Okay. Like 5.
That is your name, right?
Maddie, yeah. 6.2.
3. 6.
Okay. So the reason for collecting a large sample is a larger sample would sort of help me assume a normal distribution. Assume being the keyword. Looking at the data, it is more likely that this could be a normal distribution. So, this is what I want you to do. Enter all the data points in your calculator. And all I need to know is the mean and the sample standard deviation. You should know how to compute those by now. Do we have the mean? What is it?
4.537.
Is he right?
Yeah.
537, not 37.
The standard deviation?
1.56.
4.56.
1.56.
Because that would be surprising, but it's 4.56. Okay, so I'm assuming that the sample is normal because the sample size here is definitely bigger than 30. There are a lot more people today in class compared to the past 2 weeks. Maybe because exams are coming up. It is true, and many of you don't. I'm not telling you, but speaking. So it is normally distributed, and what does normal mean? I've mentioned this before. Something that has to do with skew.
It'll be a bell curve.
It'll be a bell curve. In other words, there is no skew whatsoever. So before we proceed with the rule, if I asked you, for the mode, what do you think the mode is? Mode is the most frequent observation.
Seems like it's 6.
Seems like it's 6.
I'm thinking 5.
We're thinking 5. Okay. So mode, we could simply conclude it is approximately 4.54. Because the mean, the median, and the mode, they are one and the same if the data is normal. Of course, if you get the mode directly from the data, that'll be the most accurate answer. Now, I sort of had the data, I made the assumption that it is normal, and found the mean and standard deviation, and every single thing that I'm about to do is based on those. Okay, the distribution is normal, the mean is 4.4, the standard deviation is 1.56. Good. Jesse mentioned it'll have a bell curve. So there is a bell curve. Not bad. That is 4.54 because it's the mean. And we say it should equal approximately, or very approximately, to the mode because that is the highest point of the curve. So 4.4 has the highest frequency, therefore that is the mode as well. Why is it the median? 50% of the data is going to lie below 4.54. 50% would lie above a 4.54. So when we say percent, what are we looking for? What is telling us the percentage? It is the area under the curve. So all of this area that you see under the curve would be that 50%. Does that make sense? And the same argument would apply over here. 50% of the data would lie here. Great, so that is 4.54 and that is also the median. Which percentile does 4.54 correspond to? Why?
It's the median.
Because it is the median. And also, I mentioned that 50% lies here under the curve and 50% is over there. So if you put dots of all the data points, approximately half of them would lie on this side. And if you put dots over there corresponding to the data points, approximately half those would lie on that side. That's exactly what we mean. So this would equal to P50. I'll explain what I just did. So what I did, can someone guess? Go ahead, Benson.
You added 1.56 to 4.54 repeatedly.
So I added 1.56 to 4.54 to get 5.1.
Although shouldn't that be
Isn't it
6.1?
6.1?
This is 6. Everything should increase then. Yes.
Yeah, 7.66 and 9.22.
Thank you. So I added one standard deviation to the mean, which is 1.56, to get 6.1. What did I do from here to there? Same thing, which is
Adding one standard deviation.
one standard deviation. Chloe.
No.
Cool.
No.
Eventually. That ended with 1.2. Eventually. So 1.56 brought me to 6.1. 1.56, I get 7.66. So one standard deviation there, one standard deviation there. In total, how many standard deviations from the mean am I at if I'm at 7.66? 2. Naturally, I added one standard deviation to that to get 9.22. So this particular observation is 3 standard deviations from the mean. Agree? Okay. You have to take a guess, what should these lines correspond to? You just subtract the standard deviation, so 4.54 minus 1.56. Go ahead and find all of that for me, that's negative 3.2.
It'd be 2.9.
2.98.
Yeah.
Oh,
And then 1.42. And then negative 0.14.
all of that is time, and naturally you may raise a question, oh, time cannot be negative. I agree with that, time cannot be negative, but I'm just doing this to demonstrate how we would do the empirical method. Good. So here from the mean I subtracted 1 standard deviation, then 2 standard deviations, and lastly 3 standard deviations. I don't need the data anymore. If the data is normal, which I assumed already that the sample or the data is normal, if that is true, then 68% of all the observations will lie between x bar minus s, which is 2.98, and x bar plus s, which would be 6.1. In other words, within 1 standard deviation from the mean, we would have 68% of the observations. Good? Yes?
Where did you get the 68% from?
I'm telling you it is 68%. It is 68% if the data is normal. That is the only time we could use that. But I do want you to know, Josie, I'm not making this up. There is a formula behind it. And it's a nice thing, within 2 standard deviations, I'm going to say 2 standard deviations on the right and 2 standard deviations on the left. And again, there is a formula behind that, you just have to take my word for it. And when we say percent, we are still talking about the area under the curve. So if you look right here, there is a big amount of area, so that's about 68%. As I go on either side to the next standard deviation, the area under the curve increases, and it increases to 95%. And I move further away by another standard deviation, the area increases, and it increases to 99.7%. And if I completely went over there to the left and to the right, what percent would I have? In other words, let's say I start at -10 and go all the way up to +10. What would the area be?
100.
100%. It will be 1. So the net area under the curve will always be 1. So the area in the middle is 68%. And normal distribution is symmetric. In other words, whatever percent you see on this side must also be on the other side. So I have to divide 68% exactly by 2 to find the area there and there, because the distribution is normal, it is symmetric. So what should this percent be?
34.
Huh?
34.
And that?
34.
Do we agree that 50% of the observations lie below 4.54? 4.54 is the median. We've agreed. Now, to that 50, I've added 34%. So what percent would lie below 6.1?
84%.
84%. Care to enlighten us, Benson?
Well, if 50% falls below 4.54 and another 34% falls between 4.54 and 6.1, add the two to get 84%.
So 50% lies below 4.54. To that, I'm adding 34%. So 84% would lie below 6.1. If 84% of the observations lie below a number, it has to correspond to which percentile? If 10% lies below a number, we call that number P10. If 50% lies below a number, we call it median, or it is P50. My question to you is, I'm telling you, or we found that 84% of the observations would lie below 6.1. So which percentile does 6.1 correspond to? Good. I want you to try and find the percentiles to each, corresponding to each of the other numbers using the information that you have over there. I'll tell you, or we know that within 2 standard deviations, we have 95% of the data. So let's start there and let's determine what that percentile is. A good starting point would be to divide that 95% into 2. What would that be?
47.5.
47.5. So .5% there and 47.5% there. And use the same trick that I used to find the percentiles. Wait, how much? 98? Are you rounding?
Yeah, don't you round up to the decimal?
I want the decimal.
97.5.
97.5. How did you get that, Josie?
I added 47.5 to 50.
She simply added this amount, which is 47.5%, to that amount, which is 50, everything below. 50% plus 47.5%, we'd end up getting P 97.5. The nice thing here, an easy way to compute the other percentiles, is as we went along this way, we added standard deviations and we simply added the percents. 50 plus 34 would be 84. 50 plus 47.5 is 97.5. When you go on the other side, you simply have to subtract the percentages. So what is 50 minus 34%? 16. So only 16% would lie below 2.98. Do you agree? So this would be P16. If I subtract 47.5 from 50, I would have only 2.5% would lie below the number 1.42, and that has to correspond to the 2.5 percentile. The last one, I don't want to make this diagram messy, but within 3 standard deviations, what is the percent that we have? I'll sort of do it over here. 99.7%. That is the 50% mark. So if the total amount is 99.7%, what amount should be on either side? You can use a calculator. 49.85. So we have to add 49.85%, subtract 49.85%. So if we add 49.85% to 50, what would we get? 0.9 or 99.85. If we subtract 49.85 from 50, what would we get? 0.15. Good? You with me? So, do you agree that there is a very small area below negative 0.14? And that area is 0.15. Do you agree there is a huge amount of area under the curve below 9.22? Yes, 99.85% of the area is below 9.22. So if the data is normal, then if you take one standard deviation to the right, then it will correspond to P84. 2 standard deviations to the right from the mean would be P97.5. 3 standard deviations to the right from the mean is P99.85, and so on. If I asked you, well, where should the third quartile lie, what would your answer be? Don't want an exact answer. I want you to guess. Jesse?
Two standard deviations from the mean to the right.
Q3?
I guess.
Okay. What else?
In between the median and the first standard deviation to the right of the mean.
So, in between the median and the first standard deviation to the right of the mean, why?
Because the 75th percentile is third quartile, so the 75th percentile must fall in between the 50th and 84th percentile.
So, the third quartile is simply the 75th percentile. So if I say this number is the 50th percentile and that number is the 84th percentile, P75 has to be somewhere in between. Good? So oftentimes if you know that the data is normal, you don't even have to think too much. If you understand the empirical rule, you can sort of guess what the values should be. With me? Okay. You call it z-score, I call it z-score. You call it easy peasy, I call it EZPZ. You didn't get a man can try. Okay. A z-score is merely a linear transformation where if the data is normally distributed, that is the key. Then you could take any observation x, have to say mean is mu, standard deviation is s. So we subtract the mean and divide the standard deviation. And that would be the formula for a z-score. Oh, it's x, not x bar, x minus b. It is a simple transformation. Think about it this way. You get up in the morning and you get in the shower, and what happens when you get in the shower and you come out? You are
Clean.
what?
Clean.
Clean, hopefully. So you don't just change your characteristics in the sense you don't walk into the shower as, say, a male and come out of the shower as female. Does that happen to you? Why are you silent? Well, I wish it happened to me. Life would be much more interesting. So it is like getting into the shower. You're not changing the characteristics. You are still the same person, but you just got cleaned up. So that's exactly what's happening. Now, if you're clean and you say you do yard work all day, and naturally you get dirty, right? So you can revert back to where you were, which is your original state. In other words, you can take any z-score and you can convert it back to the data value with this formula. In the simplest way possible, we can say, well, a z-score is a linear transformation similar to converting from Fahrenheit to Celsius and Celsius to Fahrenheit. Same thing, but this is just unique to statistics. Okay, this is what I want you to do. I think we have space here. What are the observations?
4.54, 6.1, 7.66, and 9.22.
All right, 7.66 over there. you can see better. I've given you the formula. And I want you to find the z-score. Let's just start with the easy one. I'm going to go for the easy one because I suck at math. So if x value is 4.54 and the mean is 4.54, what would you get for a z-score? X minus the mean divided by the standard deviation. X is 4.54 minus the mean is 4.54 divided by the standard deviation, which is 1.56. What do you get? 0. Okay, let's try these two, 2.98 and 6.1. And let me know what you get. Parentheses are important unless you're a pro as algebra. Make sure you put parentheses when you do x minus mu. Or do it in 2 steps so that you don't make any mistakes. Do you have it?
I was just gonna ask, if you use a normal distribution, isn't it just the standard deviation, -3, -3, -3?
Patience, my young Padawan learner. We are getting there. You didn't get the reference, did you?
No.
No? Okay, great. Star Wars. Yoda. What?
Not really interesting.
Come again?
Something.
What did we get for the z-score here? I want you to take a guess. So this is -1, that is 1. So that has to be,
-2.
and that,
2. -3.
going back, what did you say? Oh, I mean, what's your name?
Mia. Well, Amelia.
Rihanna?
Amelia.
A million, okay. I was about to ask you, do you have a boyfriend named Chris Brown? Oh.
No.
Well, you can't. Your name is Amelia, not Rihanna. So it pretty much quantifies the number of standard deviations an observation is from the mean. So exactly 0, which is the mean in this case. If an observation has a z-score of 0, that is just the mean. If the z-score of an observation is negative, then all those observations, or that particular observation, has to lie below the mean. If the z-score of an observation is positive, in the sense that above 0, then naturally each of those observations are above the mean. So we can connect the percentiles to the z-scores, so 0, 1, 2, and here is the question. So an observation has a z-score of 2.24. My question to you is, could it be P90 approximately? Yes or no? Yes?
No.
2.24. Why not?
Because, P90 falls between 1 and 2, a z-score of 1 and 2.
Oh, I see you're explaining it the other way around. So, what's your name?
Ashley?
Ashley said, oh, P90 has to lie between these two numbers, so the z-score has to be between 1 and 2. Or the other way of thinking would be, oh, 2.24 is right here, so if you go up, it has to lie between P97.5 and P99.85. Agreed? Yes? So the answer there is no. What about that? Could it be 3.2? Dominic?
No, because it's below the mean, so that means it should be a negative deviation.
Very good. So 3.2 is definitely below the mean, so its value has to be negative. So 2.24 is not negative, so the answer is no. We can find the actual observation using this formula, which is the reverse. X is equal to mu plus z times s. What is mu? The z-score is 2.24. Standard deviation is 1.56. And what do we get?
8.03.
8.03. 8.03 lies between 7.66 and 9.22. That's exactly what I said earlier. So it has to lie between those two percentiles. So just like the IQR rule, we have a z-score rule, and it's very easy. Any observation that is above 3 would be an outlier. any observation below 3 would be an outlier. The reason being z score less than -3, z score greater than +3. Could the number 7.1 be an outlier? No. 7.1 is right here, not an outlier. Could the number 1.2 be an outlier? 1.2 hours spent per day on the phone, not an outlier. If someone said, oh, I spend 12 hours on the phone each day, would that be an outlier? Yes. 9.22 is over here, 12 is somewhere over there. If you drop below, you would see the z-score is greater than 3. But mind you, this applies only if the data is normally distributed. Very good. So that is the end of chapter 3. I will go ahead and explain what you can expect. Exam. That'll be 16 multiple choice questions. The last one is optional. And there's extra credit in the sense if you get it right, you get 5 points. If you don't attempt it or if you get it wrong, it is not going to affect you negatively. Good? Okay. They're all multiple choice. You can bring 3 cheat sheets, front to back, typed or handwritten. Don't come with a poster. By sheet, I mean by that, a notebook paper, front to back. It can be typed, it could be handwritten, it could be color-coded. You can put anything you want. But the purpose of creating this is as you write the stuff, think about what you're putting in that cheat sheet. It is a way to learn, which is why I'm permitting this. Don't buy it from someone else. Chapter 1, we only did 1.1, 1.2, and 1.3. If you did the homework and understood what was happening in the homework, you should be able to do well on this exam. I've pretty much picked questions directly from the textbook's test bank. So the questions would be very similar. So if you understood what's happening in the homework assignment, you should be able to do well on the exam. Chapter 2 is on graphing. that raise this up? Yes. Now, this doesn't mean this is all you need to focus for the exam. This simply means I know that there are questions on these. I'm pretty confident that there are probably questions in 1.1, 1.2, and those. So place extra focus on those topics. If you have a sample, how could we find the mean, the standard deviation, the median, the first quartile, the second, and the third? Easily. The calculator. So if you don't know how, and if you want to practice, go to the back of the textbook. At the end of each chapter, there is a summary on the functions that we used in the class. So you can refresh your memory that way. Z-score is a formula, the IQR rule is a formula. You are welcome to put those in the cheat sheet. Okay? You can put anything you want. Put a picture of your cat if you want. It's going to make you happy. So these are the most important topics. But as I said, if you complete the homework assignments, you understand everything in the homework assignments, you should be able to do well on the exam. Understanding the key word accuracy.
Can we use an example problem from our notes?
Why not? I said put anything you want. I said your cat can go in there. What else? Oh, I forgot. Did someone buy the quick study guide? So if you bought the quick study guide, that will serve as your cheat sheet. Okay? So the threefold info piece, info sheet, what's that? So that has 1, 2, 3, 4, 5, 6 pages laminated and it's foldable. If you have that, that will replace these. So you can only have 3 cheat sheets, front to back, with anything on it. Yes? Even the tables. Oh, no, problems from the notes that we did in class. I do want to add one other thing to it. I apologize. Frequency distribution. I think I'm done now. If you have questions, talk to me. If not, I will see you on Thursday. to do for Kyle Wong, don't stress, meditate, do something.